Second half of section 8.4 is multiplying and dividing rational expressions. And again, rational expressions being fractions, and you're going to say, but I know how to multiply and divide fractions. Great, this will be an easy section for you. Here we go. So step one is to factor all of the numerators and all of the denominators. Once everything is factored and you've got all of the factors, and now this is going to include trinomials and binomials, and once you've got all the little pieces, then you're going to, step two, reduce anything that's in common. Now remember that for it to be in common, you've got to have one on the top and one on the bottom, one numerator, one denominator. It can be in any of the fractions involved, but you can't reduce across. All right, and then your third step is to multiply across. All right, and then I put over here with a little star, don't forget when you're dividing, the only difference between multiplying and dividing is when you're dividing, you're going to flip the second fraction, so flip the divisor and change it to a multiplication problem. So as long as you remember to flip the divisor, it's just like it is a multiplication problem. Okay, so here we go. With these, what we're going to do is this. We're going to look to see, well, 8 can be divided down to 2 times 4. And the reason that's handy is that we've got a 2. And in these are monomials, so we don't really need to, if you want to bring them down to their lowest terms, you certainly can. I'm thinking with Algebra 2, you should be able to see parts that match and don't, and you should be able to see factors within numbers already. And so if you can't, then break everything down to its smallest parts. But here's what we're going to do with monomials is we're going to look to see 8 is 2 times 4, and so the 2's, we've got one in the numerator, one in the denominator, and we have a 4, one in the numerator, one in the denominator. And here we've got 3 y's on the top and only 1 down here. So we're going to reduce this by 1x. So now we have x to the second. All right, and I'm going to do this just because it's easier. I've got a y and a y here. I could have reduced it with this, and that's fine either way. And now I've got y squared and y cubed. So 2 of them, 2 y's are on the bottom and 3 on top. So I'm just going to have 1 left on the top. So what we've done in essence, and if you need to see the parts, then feel free to do that. What we've done is we've taken, with this one, we took x times x times x times y over x times y times y. And so that's why when we reduced this, now we have 2 x's left. All right. So that should be something you've done already, and you can follow along and just subtract the exponents there. So now we've factored them, we've reduced, now we just multiply across. What is left? We've got an x squared and an x to the 4th and a y and a 7. So you're going to put your constant term in front. So the 7 is in front. And then we have x to how many? We've got 2 here and 4 here. So remember when we're multiplying, you add the exponents. So we've got 2 and 4 is 6, x to the 6th. And we have a y left. All over, oh look, there's nothing left in the bottom. It's over 1. So you don't need that. If it's over 1, you can just leave it. So 7, x to the 6th, y. And you're done. Ta-da! Let's do a couple more. On this one, we've got binomials and trinomials. So we do have to factor these out. What I'm going to do is just factor them out right here all together. So if that confuses you, then make sure you rewrite it separate from your original problem. But for space, I'm going to just factor right above and below my numerators and denominators. So here you can look and see 5 is in common and x is in common. And what's left here is 4 minus an x here. And here we've got x, and then there's 1x left minus 1. And here, x's signs are different. 4 is 2 and 2 or 4 and 1, but I want the difference to be 3. And the bigger number is positive, so 4 and 1. So 4 minus 1 is 3, yes. And this is a perfect square minus a perfect square, so x plus 4, x minus 4. And now I've got all my parts and pieces. Now for the fun part. I love this part. Just cancel stuff out. Look for things that match. Let's see. An x matches. X minus 1 matches x minus 1 in the top. X plus 4 matches x plus 4. Here is something that might be new and different to you. I've got 4 minus x and x minus 4, which are very similar, but they're not identical. So your first instinct would be, oh, they're not identical, you can't reduce them. But oh, they're so close. Watch this. If I multiply 4 minus x times a -1, that makes this 4 negative, and it makes the x positive. Oh, this is an x, not a 4. Oh my goodness. Which is the same as x minus 4. So if you've got the same parts, just with opposite signs, you can simply multiply through by a -1 and then it will match. So what I can do is I can say, I'm going to multiply this. So I'm going to say, let's do this. Let's change this to -1 times x minus 4. All right, do you see what I did there? So I just changed this to -1 times x minus 4. Now the x minus 4s will reduce. And now all I have is -1 times 5 on the top and everything. I love it when that happens. It's just so satisfying. Okay, -5 is your final answer. All right, so that's the trick. If you've got the same numbers and variables, the same terms, but opposite signs, take one of them. You don't need to do both of them. That would kind of defeat the purpose. Choose one of those binomials and multiply through by a -1. And then make sure that you keep that -1 in your problem. Don't lose it somewhere. All right? All right, let's do one more. This one is a division problem. So what we're going to do first, and really and truly this is totally up to you, if you want to flip first or if you want to factor first. So you can do however you want. Let's do let's factor first, but because of space, we'll factor and then move it. Remember, once you factor though, you can't start canceling until after you flip. So let's factor out x and x, and this is 21, and we want the difference to be 4, so what's 7 and 3? Yes, and I want the bigger one to be negative, so 7 and 3, and this is 5 times x plus 3, and this is going to be, oh, this is a perfect square minus a perfect square, so x plus 10, x minus 10, and this one is x and 1 positive and 1 negative. I want a difference of 3, and I multiply to get 70. Oh, 7 times 10, and so I want my 10 to be the bigger number to be positive. Okay, so now before I start canceling, I need to flip. So, but I'm just flipping this one. So I wonder how far I can go with my camera so that you can see. I wonder. Oh, check this out. Okay, don't get dizzy. We're going to go down. All right. Okay, now it gives me a little more space. Okay, so then let's just move these down. X plus 3, x minus 7 over 5, x plus 3. Now remember, we're going to multiply and flip. So x plus 10, x minus 10 over x plus 10 and x minus 7. This marker is half dead. Let's switch. Okay. So now I can reduce the x plus 3s, and now in all honesty, if they're in the same fraction, I could have reduced those that were in the same fraction ahead of time, but it doesn't hurt anything that I didn't. So the x plus 10s are the same, the x minus 7, one on top and one on bottom. So it looks like I've got x minus 10 over 5. Be careful that you don't succumb to the temptation. This 10 and this 5 look like, oh, I can just reduce that out by 5. But realize that this x minus 10 is a whole binomial. If you have a binomial, if you've got pluses or minuses, those have to stay together. You can't reduce a part of that. It has to it's all or nothing. Okay? You have to either reduce the whole thing or none of it at all. Okay? So this has to stay x minus 10 over 5. All right. So now I don't know if it's going to chop my head off when I come up. Okay, so when you're multiplying and dividing rational expressions, factor all the parts, factor all the numerators, factor all the denominators, and then reduce anything that will reduce, and then multiply straight across, and you're done. This is a quick, easy lesson, and don't forget to flip your second number in a division problem and change it to a multiplication problem. That's it. All right. See you next time.